These notes are for Honors Math 3, Unit 6 on conic sections. This is objectives 6.3 and 6.4 on circles, and the assignments do have some review on parabolas. So at the top, we start with the definition of a circle, which is the set of all points in a plane that are equidistant from a fixed point called the center. I've written down the equation for the standard form of a circle. So it looks kind of similar to how we've seen parabolas look. So we have x minus h squared. We also have y minus k squared, and it's equal to r squared. So h and k, rather than being the vertex, are actually the center here. And then r is the radius of the circle. So this is the way that the equation of a circle should look. Although it's not always written in standard form. So we will see some where the terms could be multiplied out and written separately. So eventually we'll want a way to identify that we're looking at a circle. As long as we have both x and y squared, it's no longer a parabola. And as long as they're on the same side of the equal sign with the same sign, we have a circle with same coefficients. Okay, so everything basically is the same. So we're looking for hopefully positive, but if they're both negative on the same side, it's okay. And then they have to have the same coefficient as well. So we're going to start here, just basically writing the equation of a circle, starting with a given center and radius. And all we have to do is plug in the values. So we're going to take our center -3, 4 for h and k. R is 2 root 5, and we just plug everything into our equation. So we have x minus -3 squared plus y minus 4 squared is equal to r squared. So we want to square 2 root 5, so we did our radical unit last, and so squaring 2 is 4, squaring root 5 is 5, 4 times 5 is 20. And so this is the way we write the equation for a circle. So on to problem number 2. This problem gives you instead the endpoints of the diameter of a circle. So a simple sketch might help us here on this problem. So we'll just kind of write down -3, 5. Here's one endpoint. 11, -7. So here's another endpoint. And so I can imagine my circle going around here. And somewhere in the middle is my center. So I need to know what that center is and then what the radius is. So to find the center between of my segment here, I'm just looking for a point that's in the middle of their x values. So here I have an x value -3 and an x value of 11. So I'd like to know what's in the middle of -3 and 11. And so all we need to do is average the two values. So adding them up gives me 8, dividing in half gives me 4. So 4 is going to be my x value. And then I want to repeat that with the y values. So averaging 5 and -7 is going to give me -1. So that should be the center of my circle at 4, -1. So now we need to know the radius. So the radius is going to be the distance between my center and either endpoint. So this could be the radius, or over here this could be the radius. And so we could use the distance formula since we have those coordinate pairs, but really the distance formula is just based on the Pythagorean theorem. So I'm going to make a shortcut here. And I can do this with either endpoint and the center. So I'm going to just make a right triangle here with the radius as my hypotenuse. And so from -1 down to -7, that's a height of 6 for the triangle. And from 4 over to 11, that's a length of 7 for the base. And then just real quick here with the Pythagorean theorem, we'll find our radius. So 6 squared plus 7 squared is equal to r squared. And we actually don't even need to know the radius. All we really need to know is r squared because that's what the formula calls for. So right here we have 36 plus 49 is r squared. That gives us 85. So now I have what r squared is to plug into my formula along with the center. So we'll write our equation. X minus 4 squared plus y minus negative 1 squared is equal to r squared, which is 85. All right. So problem number 3, we start with an equation here that's not written in standard form. So our first step is to rewrite it in standard form, and then we'll identify the center and radius from it. So I can tell this is a circle because x and y are both squared. It's no longer a parabola. They have the same sign and same coefficient, so positive 1 and positive 1, and that identifies this as a circle. To rewrite it in standard form, like with parabolas, you're going to group all your x's together. We're going to group our y terms together, and we're going to complete the square for both the x's and the y's, and we'll move our constant to the other side. So we'll keep x squared minus 8x, and we'll leave some space. Y squared plus 6y, leave some space, subtract 9 over to the right. So we're leaving space to complete the square for each set. So for the x's, we would get negative 4 plus negative 4 makes negative 8. So negative 4 times negative 4 is 16. And we want to balance by adding 16 to the right. We'll do the same for the y's. So 3 plus 3 makes 6. 3 times 3 is 9. So we'll balance by adding 9 to the right as well. So now I have my x's ready to factor. X minus 4 squared. The y's are ready to factor. Y plus 3 squared. My 9's are opposites adding together to 0, leaving me with 16. And that's it. There's my circle. So identifying now the parts of the circle, the center. So HK, so positive 4, negative 3. And the radius. Remember that you're looking at r squared, so the radius is 4. We could also take that and sketch it if we had to. We're going to practice sketching here in the last example. And this one specifically is an inequality. So because there is no equal to sign, we're going to go ahead and graph it as dotted. And then we want to shade as well. So we'll start by plotting the center, which is at negative 1, positive 3. Our radius, remember we're looking at r squared, so the radius is 3. So a little point for your radius, for the center here, and then we'll use the radius. So 3 units down, that's going to be a point on the circle. 3 units to the right, 3 units up, and 3 to the left. So we have what we would connect with the circle, except it's a dotted circle. When it comes to shading, the easiest test point is the center, because by plugging the center back into my inequality, you automatically get 0 plus 0. And we can check real quick, is 0 less than 9? Yes. So the center is a solution and we shade inside. Remember that if your test point does not work as a solution, then you would shade the other region. And that is the end of our notes.